Hello all, welcome to the subject of VLSI Design and Technology. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department, Parvati Bai Ganba, College of Engineering, Wagoli. So today in this lecture we are going to study about macro cell. Macro cell is made up of logic circuits. Here I am going to write the line of the topic. Macro cell. The macro cell is made up of logic circuits. The macro cell shown in the figure. This is the figure of the XC9500 macro cell within the functional block. Macro cell contain arithmetic logic unit for arithmetic functions, and product term from the AND array are present in the macro cell for the primary data inputs. Okay. The product term allocator, and this figure shows the product term allocator logic, which is a rectangular box containing programmable elements, and the trapezoidal box are the programmable multiplexer. The main application of product term allocator is to control the product term, and the product terms are combined with the product term from the below or above flow S6, S7 and G2. To increase the logic capacity of the macro cell, the product term allocator is used in the function block. So this is all about the product term allocator. So next, see fast connect switch matrix. Fast connect switch matrix, which is signals to functional block input, which matrix, the fast connect switch matrix connects the signals to the function block input and output block and function block output drive the fast connect matrix. Second figure, this figure shows the fast connect switch matrix, and this figure is about for IO block and output enable capacity. Input output block, we can say it input or output block, which shows the detailed structure of input output block is a interface between internal logic and input output pins. The input output block contains an input buffer, output driver, and output enable selection multiplexer and user programmable ground control. In input output block, Two global output enables the microcells. The input-output block provides a slew rate controls and also provides user programmable ground in a pin capability. So next see Ultra Max 700 now 7000 Cpld. Ultra Max 7000 Cpld. Let's see introduction first. To realize the logic functions in Max 7000 device, double EEPROM, double EEPROM cell are used, electrical erasable, programmable, read-only memory because to because of involvement of the iteration, the Max 7000 devices are programmed. The Max 7000 family devices are combined into groups known as a logic array blocks. In order to build a complex logic circuits, the macro cell is supplemented product term and the Max 7000 family provides a programmable speed and power optimization. The second one is features. High performance second generation Max architecture, built-in JTAG boundary, scan test, and complete Cpld family, and programmable macro cell flip-flop with individual controls and programmable power saving mode in each macro cell. Let's see the architecture of this Max 7000. The Max 7000 architecture includes logic array blocks. Here, this figure will shows the architecture block diagram of Ultra Max 7000, which is having a macro cells, expander, product term, programmable interconnect array, input output control blocks. Then logic array blocks. The Max 7000 architecture is based on high performance logic array blocks, consist of 16 macro cells array shown in a shown in this figure shown in this figure shown in this figure and logic array blocks are linked together with the programmable interconnect array. So the macro cell of Max 7000 configured for sequential and combinational logical operation, and the macro cell shown in this figure, and which all the combinational logic is implemented in the logic array and provides a 5 product term per macro cells. The programmable register is clocked in the three modes by a global clock signal and enabled by a active high clock enable, then by array clock implemented with the product term. Then second one is programmable interconnect array. The programmable interconnect array, the logic is routed between the logic array blocks to programmable interconnect array. The signal required by each logic array block are routed from the programmable interconnect array into the logic array block. This figure shows the programmable interconnect array signal are routed into the logic array block. Then double EEPROM cell control one input to two input AND gates and selects the programmable interconnect array signal to drive into the logic array blocks. This figure indicates the I/O control blocks of max 7,000 devices. The I/O control blocks for max 7,000 family is shown here, which leads to I/O pin configuration for the input and output or bidirectional operation, and the I/O pins has a tri-state buffer to control the global output signals, and the I/O control block of the device has two global output enable signal. The advanced micro devices AMD Cplds. The AMD manufactures a Cpld family with a 5 subfamilies called Match 1 to Match 5. Advanced, here this figure will show. I will write the headline here. Advanced micro devices AMD. AMD is nothing but advanced micro devices which manufactures the Cpld family with 5 subfamilies called Match 1 to Match 5. The match device consists of multiple PAL and all the match chip are based on double EEPROM. The discussion will focus on match 4 because it is represents the most advanced currently available part in the match family. Here this figure, so this figure will shows match 4 chip showing multiple blocks and interconnects called central switch matrix. And for connecting the block together, all the connections in a match 4 between one PAL block and another routed through the central switch matrix. The device viewed not only as collected of PALs but also single large device since all connections travel through the same path. Timing delay of the circuits implemented in the match 4 are predictable. A match 4 PAL like block is dissipated in this figure. Here, this figure. It has 16 output and total 34 inputs. However, there are only two key difference between these blocks and normal PAL. There is a product term allocator between AND plane and macro cells, and there is an output switch matrix between OR gate and IO pins. The product term allocator distributes and shares product term from the AND plane to OR gates, requires them. The output switch matrix makes it is possible for any macro cell output to drive any of the IO pin connect to PAL block. This is all about this advanced micro devices, advanced micro devices. So next, see lattice Cplds. We'll show in the next slide. The lattice gives complemented the logic gives complex programmable logic device which two product line the lattice PLSI and ISP-LSI for both products. Lattice has their families with the different capacities and speed. The IC consists of Spld blocks and the global routing pool. Lattice also has Cpld family known as 2000 series, and the Lattice 3000 series shows the Cplds with 5000 gates, and the 3000 series gives some enhancement over other lattice families. The general structure of lattice PLSI and ISP-LSI device is indicated in the figure. This figure. The outside edge of chip are bidirectional I/O. These the outside of the chips. These are bidirectional I/O and connect to the general logic block and the global routing pool. The generic logic block are small PAL block. These are small PL block that consist an AND array, product term, allocator and macro cells. The global routing pool is set of wire available to connect the generic logic blocks input and outputs together. Then Cypress Lash 370 CPLDs. Flash 370 CPLDs. These families products similar to AMD and Lattice devices, which is based on Flash EEPROM technology. The Flash 370 parts are not in a system programmable. This figure shows the Flash 370 has a typical CPLD architecture with multiple PAL blocks and programmable interconnect matrix to connect them. Within each PAL block, there is an AND array that feeds a product term allocator, and this illustrate another type of flexibility available in PAL like a blocks in CPLDs but not present in normal PALs. The ultra flash logic CPLDs logic has in a system programmability and provides on-chip SRAM blocks. The this figure will shows the architecture of flash logic devices, which consist of PAL blocks known as configurable functional blocks. The flash logic is the same as that of the other structure. Each PAL-like block is configured as a block of 10 nanosecond static RAM. This concept is shown in the lower part of the figure shown here, which shows CFB can be used as a PAL and configured as a SRAM. In flash logic device, the and or logic configuration bits are SRAM cells or double EEPROM cells. Then the next one is ICT peel array. ICT peel array. These are large PLAs, which includes logic macro cells with a flip-flop and feedback to the logic plane, which shows the programmable AND plane that feed a programmable OR plane. The output of OR plane are divided into groups of 4 and each group gives input to any one of the logic cell. The logic cells provide registers for the sum term and which can be feedback the sum term to the AND plane. Because of PLA like a structure and logic capacity of the peel array is somewhat difficult to measure the compared to the CPLDs, and peel arrays offer relatively few IO pins, with the largest part being offered in a 40-pin package. And this shows the logic cell in a peel array which consists of flip-flop configurable and DT or JK and two multiplexer. The multiplexer product produces the output of the logic cell and provide a registered or combinational output. The logic cell output connect to an IO pin. Let's see Cpld packaging. The Cpld have a large number of pins. The commonly used packages for Cplds are as follows: plastic leaded chip carrier, a CPL/CC packages contains of the pins at four sides of the chip, here shown in this figure, which contains a pin and chips around the four sides. And the second figure shows the quad flat pack, which consists a pin of all the side, which consist the pin all the sides, used in PLCC package, and the quad flat packages pins are thinner than the PLCC, and the varieties of these are available as plastic quad flat pack, and second one is power quad flat pack, and third one is 1.0 mm thin quad flat pack, and ceramic pin grid array, which is shown in this figure, which is having in this package the pins are extending straight outward, and bottom view of the FGA package shown in this figure, and ball grid array. The ball grid array packaging seems to be same as that of the pin grid array, here this one, and here the pins are small round balls instead of post. Since the pin is a BGA package are very small, hence the more pins can be provided on the packages. That is the advantages of Cpld: easy to design. Let's see few advantages. Easy to design. Second one is lower cost. Which requires a low cost due to the future of the reprogrammable, and another one is large product profit, which requires very short development cycle, because of which product time of the market is faster and generates the profits. Lower board area. The CPLD has a high level of the integration, and simple design changes due to reprogramming, and which are used in a wide applications for prototyping small gate array, and also implements the graphics controller and LAN controller and UARTS and cache controller. These are all about the Cpld. So next, see the field programmable gate array, FPGA. Field programmable gate array. In the year of 1980, when a large-scale integrated technology has been developed, the digital integrated system designs such as the microprocessor, bus I/O controller, and system timers et cetera have been fabricated. However, in order to connect the large integrated circuits, the global control signals and the data signals from the subsystem to another subsystems are needed. To solve this problem, custom integrated circuits have been used to replace the large amount of interconnects. However, the custom integrated circuits have again some disadvantages such as the relatively very expensive cost and due to the increasing the design and time delay in time to the market. Therefore, the better solution for the designing the digital integrated system is strongly needed, and the FPGAs are the promising devices in which the entire system can be implemented on a single chip and further gives the flexibility of the programmability to the system designer, and which improves the integration density 10 times than the custom chips. And the further, by using the electronic devices, automation tools, and the system can be designed in a short time. The FPGA is a larger than the Cpld devices, and the FPGA has the different architecture than the Cpld, and which enables it to do the more complicated functions and often contains the memory in which the data can be stored. Because of the design different from the Cpld, the complexity of the CPGA is typically measured by the number of the system gates and one chip on the chip and not by the number of the macro cells. The programmable switches, fuses, anti-fuses, RAM, and non-volatile memories are provided by the different vendors. The line segments have also to be connected by the programmable switches. Here I will show the FPGA type bus base array in the next slide. The FPGA are a field programmable devices that have logic structures which can be configured by end user, and FPGA provides a affordable solution as customized and very large system integrated chips with the ability to implement logic circuit and provide the instant manufacturing turn around with very low cost prototype. FPGA can be programmed in a minutes of offer the same functionality and the performance as other and those providing the significant time to market of the advantage. Basic FPGA architecture. Here this figure shows the architecture, and it consists of the logic block, which consists of logic block and interconnection between the logic blocks and the input and output IO blocks.